Yotham. Last session, last survey. And question number 1. Benefits of transition from diesel to electric-powered underground mining equipment. And several answers. Underground health and safety, operating cost, compliance with regulation, automation, reduced maintenance. After choosing one of the answers, please scroll down to get to question number 2. And the question number 2 is opportunities for reduction the underground mine operating costs. And several answers below. Please choose your answer and then scroll down to get to the question number 3. Question number 3. Key issues in developing a mine to be a good neighbor in the local community. Noise pollution, employment opportunities, waste disposal, community projects, education, traffic movements. And the last question, question number 4. Effect of current mining regulations upon mine development and operations. High operating costs, increased underground safety, mines welfare, beneficial environmental impacts, high operating standards, more onerous requirement for technical information. Okay, thank you, Arthur.
Okay, thank you, Natalia. Now, so we are starting the last session, and our aim is to finish 5:45. So I'll pass the microphone to Peter Robinson, who is director with Metal Fair, and the session will be focusing on sustainable mining, specifically technologies and operations which are available at the moment. Thank you.
Good afternoon. Well, I'd like to start the last session by offering my congratulations to us. We've survived an Arthur conference when not a minute is put to waste, and you're still here for last session. Well done. The last session is about sustainable mining. Now, I'm an operational miner and a digger, and it's interesting what sustainable mining means to everyone in mining. But for me, the key issues of that are environmental impact, progressive restoration, progressive planning for closure, underground safety. Now, I'll be very interested to see how our speakers bring those issues into what they're going to say. And we'll start by, or Chris Bray will start us off by talking about underground mine planning and developing technologies. Chris.
As a speaker, okay, this is working okay. Thank you very much for staying along for the last session here. It has been referred to as the graveyard shift, but I think Arthur strategically put as the last session because it's a very interesting hot topic in the industry at the moment. Okay, and I think a lot of the following talks are quite complementary in different levels of details or aspects of developing technologies in the mining industry. So I'm concentrating on some of the recent experiences myself and my team have had for underground mine planning projects for developing technologies. And it's a really interesting journey actually. It's a privilege to be part of a client's team because as well as providing them with the engineering skills that you have to offer, you're also learning about these developing technologies along the way. So, front of the slide there is it's just a bit of a marketing picture from Sandvik from last year. It just there's an online video showing the development of their automation technologies for a 38-ton loader, and they showed it running through a number of glass walls there. So that was kind of interesting. Now this is a very big topic, and I see by the audience here there's quite a few people who are very active in the underground mine operations and consulting fields there. So you'll all have different levels of experience in these areas. The areas that just keep coming back very relevant and developing technologies that I've been exposed to with my teams are in the fields of rapid tunnel development, battery electric equipment, automation or semi-automation of equipment, and in some cases various levels of underground processing in mining operations. These are all very big topics, and I don't think anyone can claim to know everything about what feeds into this. It's very much a team effort. So, but at the same time, a lot of the developing technologies and concepts are not new. They were scoped out in some cases decades ago, but we're just getting the technologies now which are enabling them to be real solutions within our mine operations. In operating projects, it's not getting any easier to design a mine. They're becoming more difficult to access. You're having to think outside the box for mining solutions for new ore bodies, and we're also hit with lower grades, higher costs, and we're being forced towards these developing technologies, whether we like it or not, to find economic solutions for our clients. Okay, so it's always, from my perspective, you've got to keep, there's a lot of grey areas, so the goal is to, for our clients, is to provide clear solutions for conventional, traditional approaches to some of these developing technologies. And it's, I guess it takes quite a bit of work to maintain focus on the end goals, which in my perspective are providing a like-for-like or apples-to-apples type comparison between your conventional approaches versus the new approaches. There are lots of challenges along the way, early stage type comparative studies. You don't have all the information that you would like to have. And somehow you have to bring, with all your efforts and investigations, bring everything together so that you can provide a clear comparison to clients so they can make some pretty serious decisions off the back of it and assess whether they have the appetite for risk of these developing technologies. There's also a lot of personal challenges along the way. People do tend to get attached to new technology ideas, get very excited. Some people think they know the answer before the work's been done. Some operations have a lot of issues, challenges that perhaps they should be focusing on before considering some of these newer technologies. But it's very exciting to try and find a solution for your clients. On the topic of rapid tunnel development machinery, there's pretty much all of the major underground equipment providers are looking at different solutions to break away from traditional drill and blast tunneling machinery. The types of machines have all got different strengths and weaknesses and approaches, but generally using different modes of cutting and vibrating techniques for breaking the rock, which can have significant advantages from reducing access development time, which is, it's just so important for just paying back all that initial capital for getting new projects up and running. I'd also put tunnel boring machines into that category as well, a well-proven solution to compare against these developing technologies, which wouldn't look out of place in a Star Wars set. And this just provides a breakdown of categories where you would, what I see is areas you would typically look at for refining the details so that you do have a good comparison for those different technologies to conventional approaches. This is only, as most of you would be aware, this is only possibly some of the main points that you would address. But if we look at rapid tunnel development type equipment, I mean, some of the areas that we've sort of focused on that compare the different options for machines which make it a little bit less, little limited in terms of rapid development, and you can lose some of that advantage of the cutting capacities of the machines. Is that while you might have advantages of a lot less development and a lot less ventilation and re-entry time compared to a drill and blast type activity, you've got significant limitations on the turning radiuses of some of these tunnels from on a lateral or a vertical aspect. There's all sorts of let's just say your tunnel profiles are a particular type shape. So some of these cutting technologies lose their competitiveness when you start having to take more than one cut to actually take the face. So, and the biggest risk that just comes up, and it'll reoccur throughout these other developing technologies, is just on your knowledge of the geotechnical and hydrogeological conditions in front of the working face. And a reasonable solution, it's not that often that you'll have so much data that you can have confidence in what really is ahead. But in your mine planning, you should make allowances for provisions to investigate along the way, because it can seriously have an impact on the success or failure of a type of machine like this compared to traditional drill and blast approaches. If we say battery, I'm very happy to have seen a few presentations here on different aspects of the development of battery electric vehicles, not necessarily for underground, but also for open pit. The ventilation considerations for this type of technology is the advantages are significant. You know, reduced costs, much healthier environment for underground operators and so on. However, the level at which battery technology has developed at this point in time, as we've seen from previous presentations yesterday, the cost of batteries is very significant. From a mine planning perspective, you need to put in all sorts of development depending on the charging approaches, and they all have an impact. So there's a lot of step decisions which I guess you should be communicating with management so that you can find a path for making a success of these type of technologies for battery electric equipment. The advantages, if you can get it to work, are significant, and this side of the industry is changing significantly. Battery technology is developing all the time. We all have expectations that the costs will go down in the future. So if it isn't the right technology for your mine right now, it may be at some point in the future. If we start looking at automation of equipment, probably this side of technology in underground mines is fairly reliable based on systems that are there, and there's probably more potential for these systems to just continually improve and be more responsive, quicker in the future. Just shows an example there. One of the mines that's been in the news recently is the Syama gold mine in Mali. It's reported to be a fully automated underground cave mine. I look forward to hearing more about this and hope to see it one day. But it just shows that if they can develop a system like this in a place like Mali, you can probably do it in most places around the world. So, you know, I'm trying to give the impression that while you should tread cautiously with all of these developing technologies, you shouldn't be afraid of them, because most of them, if they're at this stage now, they could be applicable to your future operation. Again, just breaking down automation of equipment into those same categories. With these are the typical sort of impacts they'll have on the mine design, schedule, infrastructure requirements, cost factors, so on. And some of these are advantages, some of these are disadvantages. And if you are looking at these type trade-offs, I'd certainly recommend maybe digesting in more detail some of the points that are up there at a later time. With respect to automation of equipment, if you're going down that path on the mine design side, it sort of pushes the planning engineer towards, in a lot of cases, pass-type systems. Pass-type systems mean other type complications, whereas you want a system that's going to be reliable and it's going to last for as long as you need it to. And I believe everything in this area can be engineered, but it comes at a cost. So you've got to go in there with your eyes wide open and not just assume that one size pass fits all. It's not the case. They can be very costly items if they're not going to be developed for the job. Sorry, running away out of time here. Just wanted to, one of the themes that is popping up more and more often is underground processing. This can be in many different areas. But we see it a lot with underground backfill plants. People don't want to move waste further than they should, and they shouldn't. But just be aware that there are some very good examples of constructed underground process facilities around the world which are probably more engineering challenged or bigger than probably most of you will ever have to consider. So you can have some confidence around that. It just shows another sort of underground sort of process facility and gives you some appreciation for the sort of excavation challenges that might be required for fitting stuff underground, taking it underground, keeping it maintained over its useful life. So there's a lot of learning outcomes, mostly management related, but maybe the most important one there, and probably everyone's had experiences, is don't make promises that you can't keep early on. Management will put pressure on you for early stage answers, which you'll be held to later on down the line. So be careful there. So just in conclusion, there's some real benefits to some of the developing technologies that I've shown you here. I think you all should consider them. So don't be afraid. The benefits hopefully will be greater than the cost. Thank you.
Thanks, Chris. That was very interesting, particularly the comments on underground processing. I think that's something we're going to get a lot more pressure for in the future, and underground miners haven't really got their heads around where that's heading. Very interesting. I'd now like to introduce Joe Gladder, who's going to talk about integrated planning with one of my sustainable issues of safety included in it. Joe.
Can you hear me now? There we go. We're almost there, folks. Good afternoon. It's a pleasure to be here, and thank you to Arthur and the MINEX Forum for the invitation to participate. I want to continue the discussion around technology and planning, but give you a little bit of a different view. I've spent most of my career in mining in the technology space, and the challenge that I see with implementing technology alone is technology isn't going to fix it. At CommitWorks, we believe that the success is really a combination of people, process, and technology. And one of the biggest challenges that we see when we talk to mining customers around the globe is they've invested significantly in great planning tools. But in a recent discussion I had with a mine manager, he said, you know, Joe, we're really good at planning. He says, the challenge we have is connecting that plan to the detailed tasks of the frontline teams that need to execute the plan. And that's where things tend to go awry. For the mine operators in the room, you'll agree this is a very common problem that we have. So this represents the typical challenge that a lot of our customers will see, is they've got great planning tools, but despite those planning tools, a lot of the tools are developed for particular processes or particular departments, and a lot of that planning is done in silos. So there isn't a good cross-functional discussion or cross-functional planning that occurs within the industry. That really results in very commonly weak compliance to plan, not only from a scheduling perspective, but from a spatial perspective. So are we chasing tons, or are we chasing the right tons? This is critical in terms of meeting our guidance. A lot of time is wasted trying to connect those plans with spreadsheets on whiteboards, and I'll show you some of the typical environments that we come into, kind of when we kick a project off, and what that environment looks like towards the tail end of the project. Because a lot of the work that is executed is really organized in the supervisor's or the shift boss's mind, sometimes they take the mine plan and they kind of throw it away and they say, I know what I need to do, I'm just going to organize my crews and do that. And the problem with that is if the face isn't ready, or the equipment isn't available, or there's other delays or other crews that are in that area conducting a survey, or there's an electrical substation that's down, they end up doing one of two things: sitting out the rest of the shift and doing nothing, which is wasting the entire shift, or doing unplanned work. Now, statistically, we know that unplanned work is 10 times more likely to result in a lost time injury, so there's a correlation with safety and planned versus unplanned work. Weak cross-functional communication we talked about as an inherent problem with the siloed planning and solutions. It really results in a culture of blame. Well, maintenance told me that equipment would be available. Well, the engineers don't know what they're talking about. They don't go underground. They're not actually doing the work of the frontline crews. So we really need to address some of these fundamental challenges that really contribute to a lot of the waste and a lot of the variability that we see within the execution of those fantastic plans on a daily and shift-by-shift basis. So that frames the problem. Front and center of the problem is this poor supervisor or shift boss that has to look at all these different bits of information and incorporate those into how they organize their frontline teams to execute the work that needs to be done. And the more complex the operation, the more difficult this is. What happened on the last shift? What equipment is available? What other crews are working in that particular area today? Who called in sick? What contractors are on site? So there's a lot of things that need to juggle in their minds in order to execute the plan as it was intended. Now, the challenge that you have is you have a number of great planning tools, as we talked about, that all do a fantastic job, but really don't connect and integrate and provide cross-functional visibility across the shift plan. So the traditional way of short-term planning, and it's 2019, so this amazes me, is whiteboards, or very convoluted spreadsheets that are laden with macros that break. There's a long lag to update those spreadsheets. In some organizations, there's one or two keepers of the spreadsheet, and if they're not available, your short-term planning really falls by the wayside. So this is the competing technology that we're trying to come up against: the whiteboards, the napkins, the back of cigarette packages. Here's a typical planning department. For the mine operators in the room, you'll recognize this. How do you get your actuals back into this? More importantly, how do you tie those actuals into developing the next shift to ensure that the next shift is your best shift? These tools don't lend themselves to productivity and reducing the inefficiencies that are just inherent within the work that needs to be done. So what's the solution? 8 years ago when the company was started, we were management operating system consultants, continuous improvement consultants. We spent a lot of time working with organizations to help understand the opportunities for improvement, streamlining that process, and in doing that, we built a lot of whiteboards and spreadsheets. But we realized the limitation and built a platform that we call Fusion. And Fusion is really designed to integrate the various planning silos and provide visibility across the entire mine in terms of what needs to get executed, ensuring that there is good data to support what actually gets done. So what was our compliance to plan? Where did things fall off the rails? And how do we use that information in order to make sure we apply a continuous cycle of continuous improvement? So this is really the goal that we set out when we built the tool. So the results of customers that have used Fusion is much better coordination and visibility across the organization. Reduced process variability, and this is really the opportunity. So we can't control the commodity price, the market does that. But what we can control is our cash cost. What we can control is our efficiency and our ability to execute against that plan. So this is really the low-hanging fruit. We can look at digitization, we can look at putting Wi-Fi and LTE underground, and there's value in doing that. The challenge is that technology does not fix the problem. It complements what we're trying to do, and that's really just by getting teams better organized. So we get them better organized, we reduce the variability, we improve safety because we ensure that what gets done is in the plan. And if it's not in the plan, it doesn't get done, or we have contingency plans. And that results in lower lost time injuries. We reduce the cost, and really critically is we provide visibility in terms of what's happening during the shift, so we can apply short interval control. Using that, we can redirect as needed so that we're not wasting that shift. And more importantly, we use that data and that connectivity, that feedback loop to ensure that when we plan the next shift, it's our best shift. What happened in the last shift doesn't matter. We need to focus on what we're doing going forward. So, if we look at that typical operational technology map, on the very bottom you have operational IT technologies that we've talked a little bit about in this conference, things like telemetry, things like IoT sensors, and so on. We can use that data and tie actuals back into the planning. We can connect the various planning silos and make sure that we bridge the gap between what's in the life of mine plan or down to that monthly or weekly plan, and really break out the details in terms of what needs to get executed on a daily and shift-by-shift basis. And most importantly, provide visibility across the organization so that we can identify any friction points between crews. So, the result is that supervisor now has the best plan that they can have. They have visibility in terms of what other crews are doing. They have visibility in terms of what happened on the last shift. They have visibility in terms of what resources are available, both from an equipment perspective and from a people perspective. So, this is an installation that we did in Canada and Northern Ontario. Prior to what you see here, they had a lot of those whiteboards and paper that are more common at most sites. We kicked the project off last year in September. We wrapped it up in December, so we take the approach of not only implementing the software, but spending a significant amount of time with our customers on change management, on embedding the use of the technology within their culture, within their processes. We're really reinforcing their operating model and driving the right behaviors, ensuring that we have visibility into the behaviors, and this helps to elevate the performance within the crews. So what you see here is a pre-shift coordination meeting that occurs every morning. These are your shift bosses or your supervisors that are all lining up. We have two 85-inch touch screens. Each of the supervisors goes up and talks about their plan for the day in front of the other departments. If there's any friction points, the other departments can say, oh, wait a minute, we can't do that because we've got to go in and we've got to do a survey, or we've got to run ventilation there, or we've got some other problem that's going to inhibit your ability to execute the plan. So then they can shift the items on the plan around, everybody commits to the plan, and then executes that plan. So let's talk about some of the results. In the 8 years that we've been in business, all of our customers enjoy these sorts of benefits, and they're big numbers, but these are real numbers. 15 to 50% increase in production. Improvement in compliance to plan, both from a scheduling standpoint and from a spatial standpoint. Reduction in process variability, increase in planned versus non-planned work. A reduction in lost time injuries as a correlation of all the work is planned, or the majority of the work is planned. And the compelling thing for a lot of our customers is the return on investment. So I can spend several $1 million on putting a great Wi-Fi system in. That's not going to fix this problem. If you have a great Wi-Fi system, it will provide you the data that allows you to get the actuals into the system and really build a better plan. And that's the goal. So let's get organized before we go down the path of spending a lot of money on technology. Once we've done that, it's about sustainability in those results. Right? We don't believe in putting a solution in place, getting results for month one, walking off the project. It's about sustainable results. And I'll give you some data to support that. And if we do this well, what we're really going to do is unlock some free cash that allows us to fund these additional transformation projects, like implementing the technologies that we've talked a little bit about. So here's some real data from our customers. Our pedigree has been in coal mining in Australia. We've since grown across the globe. But if we look at the first 6 years of our business, what you see here is a subset of data from Queensland, the state of Queensland in Australia, and over a 6-year period, the improvement in productivity that the average mine saw, and that's about 28%. Our customers enjoyed an improvement of about 68% in terms of productivity. So pretty significant increase because we reduced a lot of the variability, we reduced a lot of the unknown, we enable greater communication, better orchestration, and that drives much better performance. Here's the correlation with safety. If you look across that same data set, the segment of the industry there saw about 7.4 lost time injuries over that 6-year period. Our customers saw about a 21% reduction in lost time injuries at about 6.1. So this is a slide I'm most proud of. I lead the North American team, and this was our first project with Barrick Hemlo. For those of you that are familiar with Barrick, Barrick has a number of mines within the portfolio. Hemlo was their mine that was the poorest performing mine. And there was rumors that they wanted to get rid of it with a lot of the changes that have occurred over the last few months. So when we started to work with Hemlo, we looked at the data, we looked at their production for 3 quarters prior to the kickoff of the project, and they produced about on average 40,000 ounces of gold per quarter. We kicked the project off in September last year. We spent almost 3 months on site implementing the software, and then a lot of time with change management and coaching and really embedding those behaviors and moving the users along the maturity curve in terms of the adoption of the technology, driving the right behaviors. And in doing that, the results speak for themselves. Q4, they saw 52,000 ounces of gold. Q1 2019, they saw 55 ounces of gold. So a very significant increase, about a 37% increase in production. Not all because of the software, but really about the combination of people, process, and technology, the right behaviors, and the software reinforcing those behaviors. So if you look at their 2019 guidance, this is telling as well. 2018, they achieved 171,000 ounces of gold, but look at their cash cost. Cash cost almost $1,200 an ounce. Tough to make money. 1,300 is okay an ounce, but we're getting close. For 2019, their guidance is sitting at 200 to 220,000 ounces with a cash cost closer to about that $900 mark. So in order to commit to this, they clearly have to have confidence in their ability to execute. They have to have confidence in terms of their ability to contain their cost. So a couple of quotes from our customer. This was the fellow at Barrick. He was the underground superintendent, and I won't read the comment to you, but he says, we saw immediate payback in terms of opportunity to really remove some of the inefficiencies and ensure that we had the equipment in the right spot, in the right stope at the right time. This was another example of a customer from Rio Tinto that subsequently sold the mine. And in implementing Fusion, they were really able to reduce their cost and get a much higher valuation for that property. And I'll skip through some of these, but these are some of the customers that we work with. Our start was working with Anglo back in 2011, and we've since done a lot of business with Rio Tinto, Glencore, BHP, Barrick, and others. Thanks very much.
Thanks, Joe. Very interesting and very important. Operational planning is the key, because if you can't get all the clever bits that we've been talking about transferred down to the people that dig the holes, the value's gone. I'd now like to introduce Hannah Bowes, who's going to talk to us about open pit planning with that keyword electric.
Thanks, Mr. Chairman, and ladies and gentlemen, for this opportunity. Following the previous talk and Chris's presentation, I'm going to talk a bit more about the open pit side of things. So at SRK, we often get requests from clients to provide a scenario for autonomy, especially autonomous haulage. And more recently, there's some exciting advances in electric trucks as well. So my presentation, I'm going to take you through some of the considerations which we've learned over time regarding open pit planning for autonomy. So the first commercial autonomous mine haulage research program started in the 1980s. Both Caterpillar and Komatsu. And this table is showing some of the existing applications where the mines have got commercially available trucks implemented. Obviously, there's a lot more operations that's either busy with R&D on autonomy or busy looking at new solutions. Most OEMs nowadays have got are busy with it, Volvo, Derek's, even Bellas. So basically, this what I want to say with this slide is it's starting to mature. At the moment, a lot of this is centered around the bulk ore commodities, the iron ore mines in Western Australia, as well as the oil sands in Canada. So it's synonymous with straight haulages and wide loading areas, wide open spaces. So there's not a lot of information publicly available due to the proprietary nature of autonomy, especially in mine haulage. There are some published data available recently from the Colorado School of Mines article suggesting you can expect on an autonomous haulage scenario productivity improvements 15 to 20%. Obviously, the operational savings is due to lower overall labor costs. So each truck would need 4 operators if you're working on a 4-shift system. You now need to replace this with 1 technician or technical expert. So it's not that you do away with all labor, it's you just have to have more technical people maintaining the systems and so forth. Accurate dispatching systems. With autonomy, you're very much dependent on your dispatching system, so there's no dispatching engineer overriding the system on a daily basis. There's also reduced cycle times because history has shown that so far that autonomous trucks can achieve 6% higher speeds. There's also eliminating shift changes and breaks. So most open pit mines, the first and the last hour of the production shift only achieves about 50% of the target for the hour because of shift change. Then also effective utilization, similar to dispatching systems. A lot of the maintenance systems is also used according to its intended purpose. And then also with safety, because you're removing staff from the operations, there's less exposure to risk. And there's also some opportunities for semi-autonomous, where an operator could use a television screen and a joystick to remotely operate the truck. Advantages of this is, you don't have to also think about fly-in, fly-out infrastructure required for most remote locations. So from the article, the bubble on the right, you're looking at 15 to 20% productivity increase. This is because of maintenance savings, tire wear, fuel consumption reduction. So overall, in an autonomous scenario, you're looking at about 30% operating cost savings. So this has been talked about a lot. I think everyone can logically derive that autonomy would have some cost implications and benefit. What I get excited about as a mining engineer is, especially in open pit mine planning, if you lower your mining cost, this would have an effect on your reserves. So if you think about the typical mine value chain, if you can reduce your costs, you could potentially increase your reserves. If you think about a pit optimization using the Whittle software or similar pit optimization software, a reduction in cost would typically increase your pit shell. This would have an effect on your downstream value chain in terms of your phases, mining schedule. You need to reconsider your cut-off grades, often blends, stockpiling. So the effect, the downstream strategic benefits of autonomy has got its place as well in the integrated mine plan, and you need to think about this holistically. Whittle did an assessment, financial assessment in 2018, testing this as a concept, what would be the typical downstream benefits of autonomy. So if you look at the waterfall chart on the right, they assessed from 478 million NPV, they can increase the overall NPV by about 37%. And 12% of that is due to the net autonomy improvement associated with the reduction in cost, but 25% of that increase is actually due to mine planning and design opportunities. So even though this is conceptual, it does show that there might be some significant downstream strategic benefits in autonomy that is often underestimated. So the approach to their study, they used costs based on autonomous operations in Western Australia. They assumed 700 to 1,000 additional hours per annum, which also this per truck, so that means there was a reduction in the overall fleet. Tire replacements were scheduled at 6,000 to 7,000 hours instead of 5,000, which is typical. A reduction in costs meant that the pit needed to be re-optimized, so the Lurch-Grossman algorithm produced a larger, more profitable pit. Because autonomous haulage uses high-precision GPS, which is accurate to centimeters, there's a lower passing tolerance on trucks, which they expect. So they also incorporated this in the ramp design, which would affect the overall slope angle often. Needs to be confirmed by a geotechnical study, of course. Autonomy can be better coordinated through periodic two-way passing lanes. There's a lot of potential for that. And because you've got less human operators in your pit, the severity of a rockfall would obviously be reduced, so there's potential for looking at higher risk slopes, basically. Of course, this is conceptual, and we would definitely advise if any of these considerations incorporated, you do it in a proper geotechnical study. So CAT 793s was used in the Whittle scenario, costing about $1.5 million to adapt a truck to autonomous haulage. So the standard rule of thumb haul road design, which at the bottom is showing 3.6 meter clearances, was reduced to 2 meters. There's a lot of suggestion that it could be even less, but to be on the safe side, 2 meters. And in considering the kinematics of the slope, they were able to reduce the overall slope angle from 40 degrees to 42.1 degrees. This is, of course, due to the spiraling effect of your ramps. In their case study, the ramp spirals about 4 times around the pit, so obviously a reduction in your haul road width would definitely have an impact on your overall slope angle. In considering the kinematics, they also were able to reduce catchment berms from 8.5 meters to 6.4 meters, which further increased the overall slope angle to 45.1 degrees. Now, if you think about pit optimization, if we test sensitivities around slope angles, 5-degree increase in your overall slope angle could have a significant impact on your pit size as well as your economics and cash flow downstream. So it's a very interesting sort of look, and all of this has got potential because of autonomy. When designing whole open pit for autonomy, there's a lot of considerations which you also need to incorporate in the design. It prefers simplistic routes, loading and dumping and stockpiling locations, as opposed to complex ones. Minimal intersections is ideal. Wide loading and dumping areas as opposed to narrow ones. You also want well-maintained roads rather than rough and undulating surfaces. You also want to segregate your autonomous haulage area from manned operations as far as possible, if you stand to benefit from the reduction in risk. And you also prefer straight roads with low curves as opposed to tight roads, winding, and also a constant gradient as opposed to a varying gradient. Now, all of these considerations already, if you're able to implement them in a conventional open pit mine, you already stand to benefit a lot in terms of productivity, which is further improved by the inclusion of autonomous haulage. So some future considerations that looking quite exciting. These are still in research and development phases. Komatsu have partnered with company eMining in developing this e-dumper 63-ton battery electric truck. It's got a 4.5-ton battery. This is the largest commercially produced battery in the world. Energy is from the downhill is stored in the truck, similar to a typical electric car. From this, it's able to produce or able to operate for 3 days, but then it needs to be charged for overnight. So there's still a couple of challenges. What's quite exciting about fully electric trucks, with the electric wheel motors, you got much higher torque, 9,500 Newton meters compared to typical diesel truck of 3,300, similar size. So eMining claims that this truck can easily do 13% gradient ramps. The only real limitation is the grip on the road. They say it can do even more than that, so that would also have an effect on your overall slope angle potentially, if you look at that in your investigation. Costs about $1 million to retrofit this truck with a battery. And some exciting things about this as well. They had to consider using Dura trays because the truck doesn't produce any heat, because it's much lower carbon emissions compared to diesel. I'm quite excited about these small little 15-ton trucks from Volvo. So essentially they're looking at replacing a big haul truck with these fleet of smaller trucks almost running next to each other like a little conveyor. It's got bidirectional loading, which means it doesn't need to reverse when it goes into the loading spaces. And it's got a battery that lasts long enough just for a cycle. It has to be charged 1 minute after every 8 minutes. It's quite interesting because if it can only run one cycle, it doesn't need such a big battery. So in conclusion, 50 to 75% of the overall value in autonomy can be unlocked by incorporating this consideration into your integrated mine plan. You have to re-optimize your pits and phases based on these savings. There's potential for steeper ramps. The conceptual financial analysis showed potential for 37% increase in the NPV, but you would have to reconsider your haul road design and your pit design, and then the smaller electric haul trucks looks to have some really interesting opportunities. So recommendations, ideally if you're looking at haulage using autonomy, 12 million tons per annum, 6 to 8 trucks running, sort of the rule of thumb at the moment. You'd have to consider, firstly, we'd recommend in a conceptual scenario, strategically, quantify the opportunity first before you go further into investigations. We suggest a mine planning operational audit because the biggest challenge is actually the change management. The technical part of it is actually less of an issue when it comes to implementing an autonomous mine haulage. But for greenfield studies, your forward-looking mine plan, you can already consider, is your mine autonomous ready to be investigated in the scoping phase? There's some references for further reading. Thank you very much.
Thank you, Hanu. One step further to the minerless mine, eh? Utopia. Can't wait. I'd now like to introduce you to Felix, who's going to talk to us about mining consumables, which key, recognizing our mine sites are all over the place.
Hello, good afternoon. I'm really glad to be here talking to you guys. Thank you for the MINEX organizers, to Peter, Arthur. So I'll try to be brief, really straightforward on the message we would like to deliver as a company. When I was developing this presentation, there was a huge, big temptation from our side just to make a sales pitch and try to incorporate all different elements here just to sell you my products. But really looking at the intention and the main idea behind sustainable operations into the mining industry, I'll be focusing on what we do in our company today to really support these efforts, and what is there that we are always working along with our end customers in such a way that we are supporting this sustainable approach to mining. So I would like to start showing you some video about our company.
There are things out there, beyond the cities,
Има неща извън градовете.
beyond the lights. Valuable things that exist at the very ends of our world. Things that are so precious, they allow ordinary people everywhere to enjoy life's simple pleasures. There are also people out there bravely exploring, discovering and developing these precious resources. Skilled, committed people who venture to these far-off places to build the mines that deliver the resources needed in every corner of the globe. And while few ever spare thought for these new age explorers, we do. For us, these companies shoulder the responsibility of progress. They keep society moving forward, building sustainable relationships, and developing the communities they work with. And we proudly stand beside them. In fact, we go with them to these places out there that others deem too hard, too far, or too costly. We go to liberate the value of every resource. We go to the ends of the earth.
How's it going? Good, good. How are you doing?
With them and for them, to ensure our finite resources are responsibly used, while never compromising on safety and always fulfilling our promise. We are Molycop, and we're in the business of liberating value for those we serve. To the ends of the earth and back.
This is what mining for us is all about. Is working along with mining operations, with people that is there on a daily basis in these very remote locations, trying to liberate value that will support the development of society. So if you then try to translate this into what we do today, the products that we make in our company and the products that we always try to supply to our customers are meant to be in such a way responsible to generate value on the mining operations that we serve. The products that we sell, of course, are intended to generate a profit to our company, but not just because we will say high volumes of our products, but because we will say something that is useful, that will generate the right effect on whatever is the applications it's meant to be used for, and also because of the way we actually make these products in our own factories. Whenever we are making grinding media in all of these factories we have all around the world, we always think on how to make a product that will generate savings for our customers. And whenever we talk about that, we always think about where the raw materials are coming from, how is this product made, how efficient are we using the energy that is needed to manufacture some of these goods, and also what will be the repercussions of the use of some of these products for all of our customers. At the same time, if you look at this map, it's not just for me to show you how big we are, on how widely spread we are around the world, but also how close we are with our customers. And this is also related to what we saw in the video. It's social responsibility. In most cases, mining operations are located in faraway locations. In most countries, you need to drive 10, 12, 15 hours to get to most of these locations, and it's in the middle of nowhere. So the main idea behind having this global footprint is for us to be close to our customers. And having the ability to be there allows us also to generate some community awareness of how important it is to generate jobs and to generate some benefits on whatever is the income that the mining operations is generating, and also suppliers like us. I'll jump into specific details about other area that generates some reference to sustainability. The importance of high quality products whenever you are using grinding media. And it's really about how much you're using, how much energy you need whenever you're grinding your ore, and what will be the effect of using these products whenever you're actually working on recovering the most metal possible. We have a reference here of some SAG mill operations that we developed some trials a few months back. And we saw that the benefits of using these high quality products are closely related to savings in energy, savings in terms of the product you're using to perform the grinding effect, and also in terms of the efficiency and productivity of grinding mills. So it's not just about the price. Price is just one element, but also it's really important to know how much you are spending on other areas around the grinding circuit that will generate value for a company. This previous slide is about a product that is 0.4 carbon content, and the next one is about 0.6 carbon content. We have similar trials, industrial trials that we have very well documented in such a way that we can prove that the use of products that have been made specifically for the specific needs of customers, and at the same time they have been made in such a way that the efficiency of the raw material, the energy they've been made of are correct, are generating savings for us, generating savings for the customers, and for the end product that you are commercializing. Something that is really important for us is always to work along with end users about what they are targeting, what are they willing to do, and how to help them achieve the specific goals on their operations. It's not just for us to work on supplying products at the right price. It's for us to work along with all of our customers to know what they need, to know what they want, and to tailor-make products from start to end. Nowadays, the way ores are developing in such a way that they're changing on a frequent basis is forcing most of us in the industry to really be flexible about the supply of products we have available to provide. If you're not really on top of these things on a regular basis, your chances to really develop something good for your customers is kind of limited. When you look about technical services, all mining companies are always targeting to reduce the OPEX, to have the lowest cost of operation, the lowest cost of ownership, and to be as efficient and productive as possible. And for this, is no secret for anyone in the industry that being in this commodity world, it's always difficult to have the lowest cost whenever you're operating a mine site. So providing not just good products and good quality will allow mining companies to be really aware of what is happening, really on top of what they really need and want, and also to be able to make more money. One important area that we have today that we really consider relevant is how can we combine different products in the beneficiation process in such a way that the combination of these different products will generate some savings, some better recovery, and will improve in many ways the sustainability of most mining operations. Like it or not, the cost of how much it costs for a mining company to generate value most of the time condition the viability and operativeness of their business. So we must be there to help them. If we are not able to provide the right products, right applications, the future for our business and others related will be kind of jeopardized. One key element that I forgot to mention that it's also very relevant for us is that whenever you look at the volumes that we have nowadays in our company in terms of capacity, it's important to mention where the raw material comes from. It's not a secret that most steel mills are using scrap to generate their final products. So for us, nowadays, out of the 1.2, 1.3 million tons of raw material we buy on a global basis from steel mills, 80% of those are coming from scrap, meaning that the raw material most of these steel mills are using is coming from a recycled product. So this is something we always praise. We always are looking at alternatives in that area because we know as a fact that as much as we can support that specific efforts, we'll be in a position to provide more competitive products, good quality products, and we will serve the needs of most communities to pollute less and to recycle products as much as possible. Trying to finally give you a message about what we have and that will be really interested for you to look at is that maybe most of us have heard about the Molycop tools. And the Molycop tools is it's a tool that it's been in the market for almost 40 years, that it's about to be launched on its version number 4, that it's used for metallurgists and process operators all around the world to really look at how the process could be improved in such a way that they can generate more recovery, having a very good understanding on the parameters and operational variables. So I encourage you to have a look at this because this is something that we provide to our customers on a regular basis, that it's really useful. That at the end is directed to the exact same purpose, to be more efficient, to be more productive, and to save money. Thank you for your time.
Felix, thank you. Consumables in the processing plant, that's a big area of cost saving, efficiency, and where we've got to make improvements. So very interesting. And sticking with the theme of the processing plant, I'm delighted to introduce Paulina, who's going to talk to us about green grinding balls.
Thank you very much for your introduction. I'm not really sure it's about green grinding balls, but greener, let's call it like this. So I feel the pressure because we don't have much time and Pavel still needs to speak, so I will try to be as brief as possible. But yes, my presentation will be complementary to the one that Felix just did because we are also a producer of grinding media. And I will try to tell you how we do it by combining three things that we hope are the most important for our clients. One thing is quality, second is price, and another additional benefit is trying to use, yes, greener method of production. So, as we all know, grinding process is a crucial element in the chain of processing plants. How it looks, this depends very much on the design. They are SAG mills, they are autogenous mills, there are ball mills, primary ball mills, secondary ball mills. So these circuits can be very simple, like you see on the left, or much bigger that you see on the right. But what is very important for all operators or managers of processing plants is the composition of costs. Of course, it might differ, but this is what I tried to collect. So, of course, in autogenous mills, there are only two components of costs. One is lining and energy. That is the biggest part. And other mills, SAG mills and primary ball mills and secondary ball mills, they have this additional price component that, in case especially of secondary ball mills, is quite a big one, almost half of the total cost of the mill operation. So the question that has to be asked and is asked by managers of processing plants is it possible to purchase high quality and low cost grinding media? And we have our own solution on this question, and of course the answer is yes. And the answer consists of two elements. One is the steel that we use, and the other is an innovative process of production that we implemented in the period of the 20 years that we are on the market. So steel that we use is a recycled rail steel. So we buy we buy a rail that was used, that is changed regularly, and this is our basic and only, in fact, material. And it's a very high quality material, because this had to be very resistant, and it's perfectly good material to be recycled and used for balls. Just to show you how it looks like, so here we have a cross section of rail. For the moment, we are using only the head of the rail to produce the rails, but we are planning to use the rest, and this is a very big technical challenge that we are in the final process. We hope that we are doing the final tests, and we are quite confident that we'll be able to do it very soon. So from the head of the rail, we can produce balls diameters from 60 to 100 millimeters. From the neck, we will be doing 30, and from the foot 40 millimeters. And also from the head, we will be doing 50, so we will expand the range of our production. As for the production process, so we are separating parts of the rail, for the moment using only the head, but in the future also the rest. We heat the head to 700 more or less degrees Celsius. We cut it. We add additional heating to the process. We forge the balls, because what we produce are forged balls. We cool down the balls, and then they land in water for quenching process. And what are the benefits of this process? So first of all, short production cycle, low energy consumption, and limited CO2 emission. It's a consequence of cutting in between heating, so we don't lose the heat, so we don't use so much energy. Lower forging pressure that results in better endurance of the tools. Precise control of temperature, and low cost compared, at least as a result, our costs are much lower than of alternative technologies like casting and rolling. Thanks to this, we can achieve high homogeneity of hardness of balls. and of course this results in much better ball's endurance. And here, for the special request of our chairman, I have some comparisons, some drafts that compare the hardness, because for us we think that this is definitely one of the most important parameters of our balls. So this is a ball that's the diameter is this is the hardness, the HIC is hardness, and on this draft down we have the diameter of the ball. So this is the ball 50 diameter, and we measured a few balls of produced and available on the European market, and each of them we measured in 3 places. So basically the red drafts, this is of one ball that was measured in 3 different places, close to the surface. Close to the surface, the first measurement was done, and then just getting to the core that is 0.0 and 38 of hardness. So you can see how big the differences in case of this red one are, depending on. This was the same diameter, but just different places around the ball. The same story with this violet ball. Also, we measured it the same way. I mean, we didn't measure it. We sent it to the laboratory, so it was officially measured. And the top blue drafts, this is what we achieve in laboratories. I mean, the middle line is the one that we managed to achieve, but we know that in industrial situation, it will fluctuate more, so we also added these two more lines on the sides just to show that, okay, we are confident that it will be so perfect shape, but we are sure that it will be in between these blue lines. Here's the same for hardness of balls diameter 40. Again, the same story. So the yellow lines are the measurements done on the balls of balls that we got on the local market. And again, 3 points of measurement around the ball, and they are very much different hardnesses depending on the same. This was the same diameter inside the ball, but very much different. It really fluctuated the same with the green ones, and this is what we managed to achieve in the laboratory. So these are the blue lines. Again, these are the hardnesses that we achieved. The middle line is the one that we achieved. We think that it will fluctuate, so we added this 2 more lines, and the same or even better with 30 millimeter diameter. We just had one ball of other producer, and it's the light blue line. Also very different, the same points of measurement and very different results. And what we achieved is on the top. So for the moment, these are the places we are selling our products. These are the places that we hope to start selling our products in the near future, because these are the markets we are targeting, especially visiting different kind of events and fairs. And as the final, I will show you my favorite picture of myself. This was this was done a couple of months ago in Kazakhstan during MINEX forum. We participated in MineTech business competition in Nur Sultan, and I'm very proud that we got the first prize. There was an international innovation competition organized there, and our solution was very much appreciated. And the main reason, next to the fact that it was innovative, creative, and so, was that it was very simple. Of course, it needs a lot of know-how, it needs a lot of experience. We worked on it for around more than 20 years, but this was a very pleasant success that we achieved. Thank you very much for your attention.
Alina, thank you. And on a serious note, I think sustainable mine consumables is that Paulina and Felix have been talking about is very important for the future to make us a good neighbour. I'd now like to introduce Pavel Hanzi, who's going to talk about EU legislation. Arguably, this should have been a very prominent, this is probably the most important topic that the European mining industry faces, and it is an area that certainly I'm, as an operator of a mine in the EU, am challenged with every working day. So I'm delighted to listen to how those challenges might be better understood.
Thank you. Ladies and gentlemen, first of all, my big thanks to all of you who are still remaining here. And I will give a few words about the topic that starts up with coal mining, partly ends up in mine backfilling, and might end up with ash mining from deposits. I'll be speaking of coal combustion products on behalf of the European Coal Combustion Product Association. So first of all, what we are speaking of, by definition, the coal combustion products are residue from coal-fired power plants, and there are two basic classes, ashes and desulfurizing gypsum. A few words about the association. It was established in 1990 by European energy producers and follows dealing of all matters linked with coal combustion products with external stakeholders. Our association has 23 members from 17 countries, power utilities, including also regional associations and supporting companies like ourselves, Garmers. Garmers is the global leader in the lime industry, and we follow two targets. Within ECOBA, we use ashes in our binders, and we use our lime for ash stabilization for several purposes. And by the way, we are also your fellow miners. We operate our limestone quarries. So, as I said, the mission of ECOBA is to promote promote beneficial reuse of coal combustion products and encourage the users and support the users, and to communicate with policymakers, regulators, standardizing bodies, and other important external stakeholders. I will skip the content in favor of timing, and let's move directly to the body. So, as we can see, everything is starting with coal. And as we can see from the chart, Europe is not a superpower in coal mining, but a significant player, which converted to figures means some 450 million tons of coal excavated. Lignite is prevailing, and the more southeastern Europe we are going, the more lignite we are speaking of. Then, besides this, and I should not forget the oil shale as a kind of spot fuel, but besides this, almost 200 million tons of coal of any type is imported in Europe to feed the fossil power plants. We can see that they currently keep some 17% of the primary European energy mix, and this will be gradually decreasing. This is also obvious that this will be gradually decreasing. Why? We will be speaking about low carbon economy later on. So, moving to the generation of CCPs in a power plant. In fact, it's driven by the legislation and regulations. Keeping all these elements of regulations, regs, rules, regs, legislation, the conventional power plant, and I will take an example, generates out of 1 million tons of coal incoming, some 200,000 1,000 tons of CCPs, water ash from the boiler, the fly ash that shall be removed from the ESPs, and then FGD gypsum from sulfur oxides removal, and finally they also need to remove nitrogen oxides. What does it mean in European figures? So, as a sum, some 40 million tons of CCPs are generated in EU 15 countries, and if we look, oh sorry, the wrong bottom. If we look at Europe altogether, it's 140 million tons of these products generated. Looking at the figures and looking at the timing prospect, we can see, at least at EU 15 countries, that these volumes generated are gradually decreasing, and it will continue. Not that sharply in Eastern Europe, Southeastern Europe, but in some it will decrease gradually. Why is it so? And this is what I already touched, given by the low carbon economy. Most of us are familiar with the 2020 targets of the European Union. This is the reality for us. And on the top of that, EU countries have adopted further, more ambitious targets to decarbonize the economy by reduction in greenhouse emissions, which again will reduce the number of CCP produced and coal used. An example, Denmark does not use any coal in the thermal power plants anymore. All of them converted to biomass. So far the legislation for volumes, but it's not the only impact. There is an LCP, Large Combustion Plants Directive, and then there is an Industrial Emission Directive, which when coming in force, they will change the CCP mix in favor of more desulfurizing gypsum with less possibilities of beneficial reuse. And staying still at the legal issues for power plants, there's another thing that you miners are very, very much familiar with, which is the integrated permission, integrated approach to your operation. So not only the air pollution as a part of environmental control issues, the water pollution, but the waste. And there is an important point. Unfortunately, I don't know how many people were here yesterday. I heard at a presentation that here in Bulgaria, coal combustion products, power plant ashes are formally considered as hazardous mining waste. Very much surprising, because if we look at the European Waste Framework Directive, these simply cannot become waste primarily. The European Waste Framework Directive adopted several provisions encouraging the reuse and recycling of materials. First of all is the waste hierarchy. I will not use the pointer rather, which favors reuse and recycling to recovery and disposal. This is obvious, but not only that. 2 articles were implemented to encourage the reuse of byproducts. First, the provision of byproducts that by themselves to define what they are. So, translated in the practical world, when the ash removes the particulate collector, when it goes to the silo, it cannot be a waste. It's simply the byproduct that complies with the Article 5. And then, even if it goes to the deposit, there are conditions under which they can become the product again, so cease to be waste. The provision, the article number 6. Of course, they need to comply. Technical and environmental and health protection measures. And for the CCPs, the most important part, the most important directive for this possible recycling is the REACH. So whatever the origin of CCP is it shall comply to the REACH system valid for chemicals. ECOBA has registered 7 basic classes of CCPs in the REACH. We are the leading registrant. Let's move to the utilization. And we are getting closer to your industry. It's obvious that the prevailing use of coal combustion products is in construction, but environmental reclamation, mine remediation, coal mine grouting, for instance, are an important part of all these application chart. This is an example of ashes where the ratio of construction applications is high, but okay, the pointer works finally. Some 20% in this segment mean reclamation purposes, reclamation uses. And let me give you a few examples. High performance concrete made with ash admixture for the bridge construction in Germany. The hydrotech construction, very demanding, hydrotech concrete, very demanding for reaction heat and that stuff, where calcareous ashes were used in Greece. Conventional concrete, where cement using calcareous ashes, lignite ashes in Germany, are another example. And something that doesn't seem relevant to your industry, but it does. Because mud stabilization, soil stabilization is used widely in road construction, traffic construction, but I can give you 2 cases of mining spills stabilization with mixed binders. One of them was in the Czech Republic, just for the geotech purposes to manage the overburden management. The other one, the recent one, from the flooded mine in Serbia, where the mud was stabilized to enable construction machinery liberate the flooded excavator. Another example, concrete blocks already cited, and something, again, a real example from the mine backfilling. This is a currently running case in Hungary, where the CCP slurry, meaning ash and gypsum, stabilized with lime, are mixed to the fluid grout and used for backfilling to prevent acid mine drainage. I was speaking about construction purposes or construction products on purpose because everything that complies the construction product directives and regulations simply comply with the mining rules, basically comply with mining rules. They are softer. The first piece, very important one, related to CCPs is the construction product regulation, which first was implemented to foster the movement and use construction products in EU market. And the last revision, turning to the construction product regulation, includes important measures on hygiene, health and environmental safety, and also for sustainability. We've been speaking about sustainability, reuse and recycling many times, and we will be speaking again and again on this topic. Moving to the standardizing environment, there is a series of standards, again, for construction purposes primarily, both European group, but also the national standards specific for ashes, and these 2 ones, hydraulically binders and hydraulically bound mixtures, fully apply to mining applications that I was speaking of. And we are moving to the summary. So, just to sum up, there are 40 million tons of CCPs generated in EU15, 140 million tons generated all around Europe. Their mix will change in time because of new legislation, but in any case, they are declared as byproducts. They shall comply with technical standards and they are registered by REACH and can be used used as a replacement for natural resources, to save natural resources, to contribute to a circular economy. And we, as the Ash Association, are ready to support the mining applications on CCPs, and we are ready to communicate all the best practices in this reuse. And let me finish with a very simple statement. Like the mining operation, the operation of power plants and the CCP management is a continuous challenge. Thank you for attention.
Well, thank you very much for a talk about coal. A refresh from me as an old coal miner, it was very refreshing to finish the conference on something positive about coal. Thank you. And that, I think, draws the end to another very, very successful MINEX conference, very well organized, tiring, I need a drink, and I still admire and congratulate you on still being here. Living with Arthur's schedule is no mean feat. Thank you.